Very good. So I see two terms. Remember, we had 7 problems like this one, right, in the handout. 7. And we were supposed to get the answers, right? On all of them. Okay, good. I see 2 terms. I see that this is completely simplified, and this one has a 4 right in the middle as a factor. I'm going to put it in front. 4x minus 1 to the third and x plus 2 cubed plus 3, x minus 1 squared, x plus 2 to the fourth. At this step, I didn't do anything. I just rearranged the first term because it had a factor stranded right there in between 2 other factors. So now I see that those terms have x minus 1 in common, and I have x plus 2 in common. However, I have to decide upon the exponent. So I look at x minus 1, I see 3 and 2. What power do I pull out? Very good, awesome. Thank you, Tony. For x plus 2, I see 3 and 4. What power do I pull out? Very good. So now, what is left from the very first term? Can anyone let us know? Yes, 4 it is. And x minus 1 in parentheses. Very good. We reached this sign right now. I have to copy it. Yes? Yes, there is a 3. Very good. In parentheses. Awesome. That's all we needed to do. So now we have to simplify in brackets. I will distribute as 4x minus 4 plus 3x plus 6. And I already have the final simplified form. And please tell me what you write in parentheses. 7x plus 2. Good. Anything else? Is there anything else that you worked on and you would like us to go back to? Is this one okay, everyone? Yes? Okay, perfect. Well done. So let's continue. Whatever else you would like me to go back to? Anything else? Yes, please, Brianna, go ahead. I'm sorry?
Number 3.
From here?
Yeah.
Yes. So we have a rectangular barn with x and y. And it says that the area is 48 square feet. And they say that the length is 8 feet longer than the width. I have to write something that signifies that the length is 8 feet longer than the width. Yes, please.
So you use the area formula. Area equals length times width.
Go correct. The length is 8 feet longer than the width. What would you recommend we write? Can anyone give us an equation?
Would it be L equals, like the length equals
Good.
W plus 8?
Y plus 8. Very good. So that's good. That's good. You can use W and L. It's fine. I just used X and Y. It doesn't matter.
As long as you have the plus 8.
For the length, that's fine. Any letters. You don't have to use the letters I used. So we're going to use substitution. And we are going to replace x in the first equation by y plus 8. So then y plus 8 in parentheses times y equals 48. What type of equation is this? We always ask ourselves that question. What type is it? And the answer is? What do you think? You have to imagine that you distribute and you'll see what happens and you set it equal to 0 because it's not linear, right? You can just guess, just perform some operations before you say what it is. What will you do before you identify it? Can you identify an equation in this form? No, so what will you do? Correct, so let's write it. Very good. Okay, so now what type of equation is it? Very good. Perfect. So then how do we solve a quadratic? What do I need to do? Excellent. Excellent. How many methods we know for solving quadratic equations? 4. Will I complete the square? Can I take the square root? It's not set up that way. If I don't complete the square, I cannot take the square root. So 2 methods are out. So I'm down to 2 methods. Either I factor or the quadratic formula. If factoring takes more than 20, 30 seconds, forget it, use the quadratic formula. Can anyone give us the solutions? You want the quadratic formula? Okay. Solve it and give me the solutions. Quadratic formula or whatever else you want. Say it again. You factor? Okay. Very good. So then we have 2 options. All I want you to work on any method. Negative 12 feet and 4 feet. Which one is not acceptable in our context? Excellent. Awesome. So then if y equals 4, please plug it in here and give us the length. X equals 12 feet and y equals 4 feet. Excellent. So the product is indeed 48, and the sum of y plus 8 is indeed 12. Excellent. And that is the answer. Good. Is there anything else that you would like to go back to? Anything? Anything that you have doubts on? Any problem? Any problem? This was from this handout. I think it's your yeah. Number 6. Let's take a look at number 6. And it says, solve the equation by making an appropriate substitution. Very good. So x to the 4th minus 29x squared plus 100 equals 0. What type of equation is it? You can say it's 2 different types that you showed us. Out of the long list of 8 different types, this one fits 2. In form, not quadratic. The polynomial is degree what? 4. How many solutions we have to get? 4. So it's quadratic in form indeed, but also it's a what type of equation? And does it have a ratio and x in the denominator? Is there x in the denominator? No. So what other type of equation this fits? We just said it. It's a polynomial, right? It's a polynomial equation as well as quadratic in form. It fits 2 of those 8 categories. Good. So it says to use a substitution. So let's say t equals. Indeed. Very good. So then what is this? If that is not t squared, then it's not quadratic in form. But it is. You're correct. Perfect. So this is quadratic in form. So can anyone give us? Yes. 6. We were supposed to finish all this by today, right?
I thought when you said 2.5, but I mean like on the month, so I was working on that.
Okay. So can anyone dictate the equation? Excellent. Very good. Excellent. let's write on the side, 4th degree 4 solutions. So we don't forget.
How can you use T?
You want to use Y?
Oh, you just use T just to use it. Oh,
It doesn't matter. Anything but X.
Okay.
Anything but X. Any letter you prefer.
Oh, okay.
But X. You cannot use X. So we either factor or use the quadratic formula. Just give me the 2 solutions for T, please. Anything.
25, 4.
25 and T equals 4. Okay? So you factor, in other words, T minus 25, T minus 4. Correct. T minus 25, T minus 4 equals 0. Excellent. Good. But these create 2 other equations because nobody really cares about T. We do. It helped us solve the equation, but the answer must be given in X. So what equation is this? Very good. Equals 25. What equation is this? Good. Now, what type of equations are these? Say it again. Binomial is the type of polynomial. You're right. They are both binomials, but what type of equation? Excellent. Quadratic. Which of the 4 methods is the best to apply now? Of course, indeed. Thank you. Good. So then X equals? No. That's why I asked from the beginning. That's why I asked from the beginning what type of equation. So that rings the bell. We mean 2 solutions. And then X equals? That's why I wrote it on the side so I don't forget. Everyone forgets. That's why I wrote it. 2 and 2 solutions. Total of 4. Very good. Anything else that you work on? Anything else that you would like to go back to?
Yeah, I got one.
Yes, please. Which one? Can I copy it?
Yeah. Well, there are 2 solutions for it.
Yes. So we're solving the equation negative 0.01 x squared. Am I correct? You'll check it when I finish. Because I don't have the right glasses. Okay, is this the correct equation? Let me read it back to you, Tony. Negative 0.01 x squared plus 0.6x plus 5.9 equals 0.
Correct.
And we are asked to solve this equation.
Yeah.
Okay, perfect example. What type of equation is it? It's Tony's problem.
Quadratic.
It is a quadratic equation, and we're asked to solve. We have 4 methods. Which 3 methods I would not even think of? I will never think of factoring with these coefficients. Awesome. Which are the 2 I will never think of? Absolutely never, never, unless you force me to. What is the other one that doesn't work in this case? Taking the square root. So the only one is quadratic formula. Awesome. Well done. So then, first of all, I refuse to solve a quadratic equation with a negative leading coefficient. You can if you want to, but I will never do that. So I will multiply by -1. And what I don't like the decimal numbers. So I see that if I multiply both sides by -100, I get integers. So then this is x squared, this is -60x, and this is -590. And this is 0. So I multiplied both sides by -100 only because I don't want negative leading coefficients, and I'd rather not have decimal numbers. I multiply by 100 and I got 1. I multiply by 100 and I got 60. I multiply by 100 and I got 590. So now this is, in my opinion, more human. And I will say -60, -60 minus b plus or minus b squared, 60 squared minus 4 times a times c. I will replace or change the negative into positive because c is negative over 2 times a. It's not a mistake to put -4 and then 590 in parentheses, but you may make a mistake when you put in the graphing calculator. That's my fear. I accept any method. So I recommend do this now. Put it in one step. Of course, it's not going to be factorable. I doubt. I mean, who knows, you know. Left parenthesis for the numerator, 60 plus the square root, parentheses, 60 squared. I can write 3,600. You don't have to. Plus 4 times 590. Close the parenthesis. Close the parenthesis for the outside and divide by 2. So I got one answer. In order to get the other one, you don't have to type it in again. So just second and entry, and just go back and overwrite the plus by a negative. So that's how I get the two solutions. I don't know if, Tony, were these from a word problem? Do they mean anything, or just x equals how many decimal digits they want?
On the last, the quiz and stuff.
Okay, very good.
Homework.
Okay. Is this clear? Any questions for me? Is this better, Tony?
I wanted to see how you put it, you took it down too fast. The way you put
Let's
it
go back.
together.
Let's go back.
I have a question.
Yes, please.
Is that the final answer? You don't have to like divide.
I don't know what the problem is asking. He only showed me the equation. So I don't know if, for example, if it's length, then I will not accept the second solution. If it's just something abstract, then I will have to accept both solutions. I don't know what the problem is saying.
But since you multiply the whole equation by 100, would you divide the answers by 100?
Of course not.
Okay.
So 2 equals 2. Any equation is a balance. If I multiply this by 5 and I get 10, I multiply this by 5 and I get 10. The solutions will never change. So multiplying both sides of an equation by 100, both sides by 100, or adding 5 to both sides, or subtracting 10 from both sides, will never change the solution. It will only make my life easier.
Okay.
I'm not saying that you have to do that. I just don't want to use decimal numbers if I can avoid it.
Yeah.
Some will say I don't want to use fractions if I can avoid it. In my opinion, plugging all this, it's very easy for me to make a mistake with a period or whatever, so I prefer integers. But maybe I'm too particular, but I'm not asking you to do that. I'm saying this is what I prefer doing.
So even though you multiplied it by negative 100, the final answer, you just keep it with it?
Okay, one more time. What we learned the first beginning algebra class is that when we solve equations, if we multiply both sides by 5, that will not change the solutions. If we subtract 10 from both sides, that will not change the solutions. If we divide both sides by 100, that will not change the solutions. Is that clear? So this is what I have to assume we know. Because we multiplied both sides. Multiplying both sides will never change the solutions. What will change the solutions is when we raise both sides to the second power. There is no guarantee that the solutions work in the original problem, because that is not 100% legitimate. Tony, say it again. So that is not 100% legitimate method. It can give us solutions that do not work in the original problem. But multiplying both sides by 10, multiply by negative 100, divided by 100, not by 0 ever. You cannot multiply or divide by 0 both sides of an equation. Adding 5 terms to one side and to the other, same terms. Subtracting 10 from both sides. Those operations are carved in stone. They are legitimate operations. They will always give us what we call equivalent equations with the previous ones. Identical solutions, not identical equations, but identical solutions. Equivalent equations. Okay, is this okay, Tony?
I get the 68.60, but how did you do the 8.6?
The one with the negative.
Okay. So you look, I got you.
Okay, good. Anything else? Yes, Fiona, go ahead. From the handout?
Yeah.
Number 20. Number 20. Okay. So we are asked to find the average rate of change of life expectancy between 50 and 60. For 50, I'm given 35.8. So 50 comma 35.8. And the other one for 60, I see 60 comma 27.6. The average rate of change. What is the formula for the average rate of change? Very good. F of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. Excellent. All I have to do is just plug it in.
And we also remember that formula.
It's a slope formula. We know the slope from like forever. So 27.6 minus 35.8 divided by 60 minus 50. So you put it in the graphing calculator and just be careful. Be careful how you put it in, because if you're, and I highly recommend do it in one step. Put parentheses around the top and subtract the bottom if you want 10. So here's how we do it. Left parenthesis, 27.6. Do you expect a positive or a negative trend? Yes, because the slope is negative of that line. Very good, awesome. Minus 35.8. Close the parenthesis, and I know 60 minus 50 is 10, so I get negative 0.82. The measurement unit is crucial. Negative 0.82. Measurement unit. Say it again.
It's in years, so it would be
Years and years, okay, of age X. So it's in years per age group.
so we just put age group because that's what's on the bottom.
Yes,
So
the
whatever's
measurement
gonna be
unit
on
for
that
the
x-axis.
still years, but since it's 50 to 60, I'm gonna say age group. Yes, or just put age, but it's for age. It's,
Years of-
yeah, yeah. Very good question. Next, is there anything else? Yes, please. Yes, go ahead.
So what would be the bottom part? It would just be decreases?
The first one, life expectancy decreases each year between the ages of 7. Oh, okay. If the average rate of change between ages 70 and 80 now is negative 0.41, this means that life expectancy decreases each year between the ages of 70 and 80 by 0.41. Yes. I still have to read the other three. Life expectancy decreases by 0.41 years between the ages of 70 and 80. Life expectancy is 4.1 years. No, C is not. Life expectancy increases. No, that C is not. So I just have to read B one more second time. Life expectancy decreases.
Isn't A and B the same thing?
No, no. That's why we have to read it carefully. Life expectancy decreases. 0.41 years between the ages of.
Like it looks like they just took those two phrases and switched
Yes,
them.
but it doesn't. It says in total in part B. That's wrong. It says by 0.41 years,
But it says between.
but it doesn't say per year.
But it doesn't say it in A either. Or it says each year.
Yes. So it's
Okay,
part A,
that's
not
why.
part B. Yeah. That's why you have to be very careful and read those options several times. Good. Next question.
I have just a little question.
Yes, please.
So when I see you got 27.6 minus 35.8, and you got it by looking at the graph, I know by looking at the ages 50 and 60.
Correct.
Now, like what if I get those numbers a little off because it's not like in the chart? I know what you're doing, but like.
I'm not sure I understand the question.
27.6?
Say it again.
Okay, for the age 50, you got 35.8. The age 50.
But the ordered pair is there. It's on the graph. The ordered pair is there. It's right here.
Oh, I didn't see that. Oh, okay. All right.
I didn't make those up. They were all right there.
I'm sorry. Okay, I see it. I see it.
Yeah. Very good. Anything else? Is there anything else that you would like to review for the test on Wednesday? Yes, please.
I just have one quick question.
Yes.
So this is kind of back to the quadratic.
Any question? Yes,
How
if
do
you,
you determine whether or not to use the quadratic formula or to just do it the other way? I guess. Like,
by other way you mean, because there are four. When you say other way, which one?
well, I mean, like, I don't know, because I have a hard time determining between doing that or doing the other one where you kind of separate the middle term.
That's like grouping.
Yeah, is that what it's called? Yeah, I don't know.
Or are you talking about like when we do the parentheses?
Well, no, I think it's the so like when we
Okay,
take
one
the
more time.
first- when we take
Okay,
the-
one more time. There are four methods.
Uh-huh.
Okay. If the square is completed, you can take the square root.
Oh.
If the square is not completed, you can't take the square root from both sides. We had x squared equals 25. You can take the square root. But if you have x squared plus 5x equals 25, you cannot take the square root. So that's clear. Completing the square, never, ever, unless I force you to. And I will force you to for one problem. Factoring, only if it works. If it takes me forever to factor, forget it. Unless I'm forced to. And quadratic formula always works. Does that answer your question?
Yeah.
Excellent. Good.
Oh, I got one more question.
Yes, please.
Sorry.
No.
So then my other question is, I noticed like on our homework assignment, sometimes it was when we use the same quadratic formula, if we would just simplify like using, let's say, for example, 11 plus or minus the square root of 137 over 4. Like that's just the number going on here. But instead of, would you prefer it to be written simplified that way, or would you prefer us to write it that way? Like, would it specify whether or not we should write it?
We
to
don't
here?
care for decimal numbers.
Okay.
Period.
Okay.
It's a very good question. We don't care for decimal numbers for many reasons. Because many of them, the irrational ones, are approximations. So we prefer to see, for example, 5 plus or minus the square root of 2 over 3, not an approximation, because this is exact.
Okay.
If you put in the graphing calculator 5 plus and 5 minus over 3, then you'll get 2 approximations. This is what we prefer. Now, your book is asking you to write 5 plus or minus, let's say, the square root of 12 divided by 3, is to realize the square root of 12 is the square root of 4 times the square root of 3, which means 2 the square root of 3. So this is acceptable. We always simplify radicals. Is it a big deal? Not really. Okay? Unless the problem is forcing us to do, yes, mathematically, I have to say this is the correct answer. 5 plus or minus 2 the square root of 3 over 3. This is the correct answer. But I'm not going to be too particular in this class about that. Good. Anything else? Number 15? Of course. Okay. Any particular section of number 15? Anything that you got stuck on or?
I mean, yeah, I guess the whole thing. There's some parts that I think I would know, but
Okay. So the domain, can anyone give us a domain of this function?
all real numbers.
Yes, indeed. All real numbers. Can anyone give us the range?
-4 with a bracket to +33.
Excellent. Thank you. The x-intercepts? X-intercepts.
3 and 7.
Very good. In the ordered pair format, I will present them like this. Excellent.
Question, on this test, it just like put the left 0 of the function is 3 and the right 0 is blank, so I just put 7. Would that be acceptable on here? Just because of how it
Yeah.
is.
Yes, I understand.
'Cause
Yes.
normally I would do that, but 'cause I
Yes.
had to put it out, I did
Yes,
that.
I didn't read that part. I'm sorry. Yes. Y-intercept, please.
Yeah.
18, 19, 20, 21, 22, 23. Yes, it appears to be y equals 21 in ordered pair format, 0, 21. Very good. Intervals on which the function is increasing.
-4
Not from which value till which value. Where?
Was it
Not from what to what.
5, 7,
5,
7?
5 to
Oh, I did y instead of x.
5 to.
How do you finish?
Excellent.
I did the y instead of x. That was
There would. So if you remember, we are talking about the intervals. We are of x. We are talking about the trend. We're not asking from what value till which value. So I gave you that question, that example all the time, and I'm gonna give it again. Somebody's salary between the year 2000 and 2010 was increasing. Between 2010 and 2005 is constant. We never asked the person from which value to which value. He only told us, he or she told us, between these years, the salary increased. That's the question for increasing and decreasing. Good, excellent. Decreasing. So F is decreasing indeed between 0 and 5. Notice that these are always open intervals. No brackets here for the increasing, decreasing. So F is constant on.
negative infinity 0.
Very good, awesome, good. The number at which F has a relative minimum. The number at which it has a relative minimum. Yes. Yes, indeed. So X equals 5. So now the number, the relative minimum is the next question. How much is the relative minimum? Yes, y equals -4 is the relative min. F of -6.
Wait, so the relative min is it's 5? No, what? Sorry.
F of -6.
-3.
F of -6.
Oh, I went 5.
Very good. The values of x for which f of x is -3.
I went the wrong way.
That's okay.
It would be 21. No,
F
it's the
of
opposite way. Sorry. No,
That's
no, it's right. Is it 4?
It is for
Then I did that one right. Yeah.
x equals 4 or
Or
7 is on the x-axis. That's okay.
oh, 21. Is that what you're saying?
So
Because
f of x equals -3 means this. It hits the graph in 2 points and I read the x values.
it's
And I
so
see
small.
4 and that's true. I agree. I agree. 4 and 6. Yes. The values of x, is f even, odd, or none of the above?
Neither.
Exactly. Not symmetric. Good. Is there anything else from this handout that we would like to go back to? Please, I have not written your test. When I write your test, I'm going to go back to problems that we did in class. That's one other reason why I have them in the system. So I will look at those problems and create and write your test. 16? Of course. So please redo all problems we did in class. I was hoping you did that this weekend. I was hoping. Okay, 16. So we have f of x equals 1/2 x squared, x less than 2, 5x minus 4 for x greater than or equal to 2. We had a similar problem in class. Let's do it. 15. 16. So please understand the method or use your own method, but you will not have the option of choosing a graph. So you have to show all your work. Okay, so please. First thing I do, this is what type of function?
A piecewise.
Excellent. First thing I do, I replace this by the interval notation, and then I replace this by the interval notation. Then I have to identify the domain. So what is the domain of this function?
Oh,
Exactly, I have everything, negative infinity to infinity. Then I start a table and putting the domain in it. I have to have 0 and I have to have 2. 0 is always part of the chart, even if the function is undefined there. But now the key x value is 2. So next step, yes, but please remember they are touching. Do not leave an empty space in there. Okay, so now I want to identify, in order not to mess it up, that between negative infinity and 2, I have to use 1/2 x squared. And then between 2 and infinity, I have to use 5x minus 4. You can say this is an overkill, I don't want to put it there. You don't have to. But I put it in there because sometimes these two branches are not given in the correct order. And I may look at the opposite branch and make a mistake. So I recommend do that. So when I plug in 0, I get 1/2. 0. When I plug in negative 2, I was thinking of the next step. When I plug in negative 2, I have 4 divided by 2, which is 2. And when I plug in 2, 4 divided by 2, I still have 2 inside the parenthesis. Now when I plug in 2 on the other side, I have 10 minus 4 inside the bracket. And let's say I plug in 3, the smaller the better. So 15 minus 4, 11. That's all I need to do. And I'm hoping that this problem will just take 1 minute of your time on the test. Because really, I think it's not much. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so I start from left to right, negative 2, 2. So it's this point. Then 0, 0 is this point, and 2, 2 is this point, but see, it has a parenthesis, so it has to be an open point. With transformations, we reviewed this function so many times, and we graphed it last time so many times, I know exactly how it looks like. Then on the other side, so this is done. This piece is done. Now I'm at 2, 6. 2, 4, 6, I think it's this. And then at 3 is 11. And this is the graph. You don't have to present the graph in 2 colors. I'm just presented it in 2 colors for you to see that they have no connection. For someone who graphs something like this, I can only give 0 points. This is not what we're asked to do. We're not asked to extend the graph from the right-hand side towards the left and from the left towards the right. So this will be a terrible mistake. This is not even a function. By the vertical line test, it's not a function, but this one is. So on negative infinity to 2, as you see, I have this graph. On 2 to infinity, as you see, I have this graph. Yes, please. 3 times 5 is 15. 15 minus 4, 11. This is a linear function. I need at least 2 points. Yes.
when you choose your point, you can choose any number because
It has to be in that interval. It has to be in the interval. But there was no point in going beyond getting a huge number.
I have a question.
Yes. Bree, is this okay? Is this okay now, Bree?
Yeah.
Okay, yes.
You have to go over A, B, and B on number 10 and show how
Which number is it?
Number 10.
Number
A,
10.
B.
A and B.
I have a hard time like looking at the graph and reading like really finding the notation for it.
So the function's domain between negative 3 and 0. The function's range between negative 1 and 8.
So I
And
got
8
it.
would be a soft curve.
See, I got the range right, but the domain for some reason, when I was looking at it, it was 0 and 1, but I don't know why.
The domain is from the leftmost point of this function till the rightmost point of this function on the x-axis. from the leftmost point. Just draw a vertical line from the leftmost point to the rightmost point. And it's negative 3 to 0. Is that okay, everyone? The x-intercept, negative 1, comma 0. The y-intercept, 0, comma negative 1. The function value indicated below, which is f of negative 2. Can anyone give us f of negative 2? I think it's close to 4, but I'll accept 3 or 3.5. Difficult to read. Anywhere between 3 and 4, I'll accept it. Good. Anything else? Yes, please.